Hello, I'm Nisar. I'm a student at IIIT Hyderabad. As part of a course in information retrieval and extraction, I had to make a text processing framework for Gujarati language. The result is this, indicNLP. indicNLP is a text processing framework for Indian languages. So, as I said, initial plan was to make it for Gujarati. But as I started, I realized that Indian languages are more or less similar. Most of Indian languages are similar in nature, and it does not make sense to create the same tools again and again for different languages. So I went ahead and created a single framework for a set of tools for basic text processing that works across Indian languages, that can work across Indian languages. Many of the tools can actually work for many other languages too. The most of the experiments I did was primarily for Gujarati and Hindi, mostly because I don't know any other Indian languages. So the framework includes these tools: Tokenizer, stopword detection, stammer, part of switch tagger, variation identification, and document classification. We'll go through each one of them one by one. So Tokenizer and sentence breaker. I developed a Tokenizer that works for 14 different Indian languages, written in a lot of different scripts. I forgot the number anyway. So the languages are written in different scripts. So let's take a simple look. So let's try. Tokenizer. Let's try it for Gujarati. Tokenize. Tokenize. Let me get a sentence from here. Yeah, so the sentence is Dr. APJ Abdul Kalam Bharatna Rashtrapati and a Vaignanik Hatha. Let's see what token says. So tokens is basically the list of sentences and tokens in it. So let's print just one sentence, just the first sentence. Yeah, so these are basically two tokens. The Tokenizer is extensible for all the Indian languages. Currently, it perfectly works for Gujarati and Hindi. For other languages, it requires some more data. So it works, but does not really work well. Anyway, so let's get it. So next is stopword detection and removal. You can give it a fairly large amount of data, and it actually counts the frequency of words and detects that these are the stop words, and later when you want to use it, you can use it. So for this sentence, let's try. So as equal to dot stop words for Gujarati as dot remove tokens. Well, it removed. So let's again print it in the same way. Yeah, so here the last dot, the full stop, and ane is removed, which are actually the stop words. Okay, so this is stopword removal. Next is stammer. I used a lightweight rule-based stammer. You basically provide a list of suffixes for each language, and it removes the suffixes from there. Major issues were it's difficult to come up with a list of all the stammers, all the suffixes, and it actually overstamps. So this is really basic method, but it has some issues, obviously. The next is part of switch tagger. I use the CRF based approach for the part of switch tagger. I actually ran the tagger with different features on Gujarati and Hindi on ILCI Corpora. I actually got for Gujarati, I got 91.58% of accuracy on health corpus. And yeah. Identification variation. So identification variation is basically spell variation. You can check the same word written slightly differently. We want to treat them as one for any IRE applications or in many NLP applications also. Right? So my approach was to create a rule-based identification variation identifier, where you can give rules that these two pairs of syllables or these two pairs of spellings are similar, and it once the rule list is there, when you give two words, it goes to the rules and tells you that if the words are actually same or not. The last one is document classifier. Name-based classifiers are known to work for document classification and filtration, spam filtering, and all such problems. I use the same name-based approach. On a news corpora for Gujarati, I had around 70,000 samples, 70,000 news articles with predefined categories. I use 80% of them for training and 20% for testing. Same for Hindi, and I got around 94% accuracy for Gujarati and 85.26% of accuracy for Hindi document classification, which are pretty nice actually. Okay, so all of these modules are can be easily used with the library. You can see classifiers, common data sets are helpers and helpers. PS, taggers, spell variations, timers, shop word, tokenizer, variation identification, etc. etc. Right. So yeah, these are the models. Now let's see something more about the framework itself. So one of the major issues with such experiments and such frameworks are that they are not really maintained, or they're difficult to maintain and difficult to extend. So my idea from the beginning was that to build a framework that can be used easily and then that is extensible. So currently the framework supports some of the Indian languages. I might want to add more languages in future. Even right now, Indian languages, I can add more languages, right? So to ensure that the code quality and quality assurance, so these are some of the steps some of the things I did. The code is completely compliant with FlakeIt standard, that is PIP8 plus PyFlex standards. Unit tests are written for some of the cases, and we can extend the unit test. The current code coverage is 41%. The tests and the standard check, the common stuff, these are checked. And also yeah, the last point, I tried to keep the dependencies of the framework minimal. Many times dependencies are outdated, and because of that the framework doesn't work. So right now the frameworks only requires one external library, that is Python CRF suite. Otherwise everything else is included, and yeah, so that's basically it. In this presentation I only included what works in very brief way. For detailed report on experiments or documentation, please go through the GitHub repository for documentation, or for experiments and all, go through the project report. Here are the links for GitHub repository and homepage and project report. So yeah, that's it. Thank you very much.